Welcome to the Unit 6 video on complements and unions. Before we get started, I want to discuss what a complement and what a union is. These two things will be used when we look at different probabilities. The complement simply means not in an event. So, for example, if we looked at all the different values in event E, the complement of E would be all the values not in E. So an easy way to remember this is just to remember that complement means not in. If we were to look at a probability, so for example, if we wanted to find the probability of drawing a king in a set of 52 cards, we would say that the probability of this would be equal to event E. So the complement would be the probability of the cards not in E, or in this case, the probability of a card not being a king. And we notate that with a hyphen next to the E. So complement is not in a set. Next, we'll look at unions. Union means to join. So when we're asked to find a union of something, we're looking at two events. We'll call these E and F. And the union of those events will be all the objects within E plus all the objects within F. So we're joining the objects within both events. Now that we know a little bit about the language of complements and unions, let's begin our examples. We're going to begin this video with a probability question. We're going to review probability because complements and unions use the probability formula. Question 1. A pair of dice is rolled. What is the probability of getting a sum less than 9? The probability formula is P of E equals N of E divided by NS. E, or the event, in this case, is a sum less than 9. So N of E is the number of times that the event occurs, and NS is the total number of possibilities within our set. I've listed a diagram of all the possible outcomes of rolling a pair of dice. First, we're going to count the total possible outcomes to get our NS. So if we count each pair, we'll see that there's 36 different ways that we can roll a pair of dice. So NS is 36. Next, we'll identify all the pairs in which the sum is less than 9. We'll start at the first cell. 1 plus 1 is 2, which is less than 9, so we'll circle it. 1 plus 2 is 3, that's less than 9, so we'll circle it. We'll continue this process and circle all of the ordered pairs whose sum is less than 9. I'm not going to circle 3, 6 because 3 plus 6 is 9. And my question wants me to find a sum less than 9, not equal to 9. Now that I've identified all of my pairs, I can count up the number of pairs that I circled. This will be my NE. I should have 26 pairs. My probability becomes 26 over 36. I want to reduce this into simplest form. 26 and 36 are both divisible by 2. So we'll divide the top of the fraction by 2 and the bottom of the fraction by 2. 26 divided by 2 is 13, and 36 divided by 2 is 18. Therefore, my probability of getting a sum less than 9 is 13 out of 18. Question 2. If 3 coins are flipped, what is the probability of obtaining at least one tail? We're going to use the complement formula in order to solve this question. Now again, the complement means not in. And the complement formula for probability is the probability of event A equals 1 minus the probability of an event not in A, or the complement. Now for this question, it's easier to find P of A complement, or the probability of the event not in A. So we're going to find P of A complement. To do this, we first need to identify what A is. Well, A is an event, and it's in our question. A is equal to obtaining at least one tail. So if A is obtaining at least one tail, since A is obtaining at least one tail, then A complement is the opposite. The opposite of obtaining at least one tail is obtaining no tails. The complement in this case is easier and quicker to identify. That's because if we're flipping 3 coins, we know that each coin either has a tail or a heads. Now, obtaining no tails, all of my outcomes are going to obtain tails except for HHH, which is if I only obtain heads and no tails. So right away, I know that there's only one way to obtain no tails, which is HHH. So I'm going to use that information to solve my formula. The probability of A equals 1 minus the probability of not in A. Step 2 requires me to find the probability of not in A, or the probability of obtaining no tails. As we just went over, the probability is the number of times the event occurs over all possible outcomes. Obtaining no tails occurs one way. And since we're flipping 3 coins, each coin has an option of tails or heads, then ns is 2 to the third power, so my probability is 1 over 8, or 1/8. Next, my final step is to find the probability of A, which is the event of obtaining at least one tail. To do this, I'll use my complement formula, which says P of A equals 1 minus P of A complement. I'll substitute the value that I found in step 2 for the probability of A complement, and I'll just subtract these two numbers. First, I need to convert 1 to a fraction with a common denominator of 8. So this becomes 8 over 8 minus 1 over 8. 8 minus 1 is 7, and it's over the denominator 8. So the probability of obtaining at least one tail is 7/8. And this is my final answer. Question 3. What is the probability of getting either a heart or a king when drawing a single card from a deck of 52 cards? This problem describes two events. First, we want to find the probability of getting a heart. Next, we want to find the probability of getting a king. We're going to call the probability of getting a heart event A, and we're going to call the probability of getting a king event B. Since these are two separate events, and I'm asked to find the probability of getting either one of these, then I know I need to use the union formula. The formula for unions is the probability of A union B equals the probability of A plus the probability of B minus the probability of A intersection B. Let's draw a diagram to visualize what this formula is doing. Let's say that we have the probability of A. So this is event A. Next, we'll have the probability of B, or event B. We want to find the union, which means the joining of the two events. So in other words, we want to encompass all the events in A plus all the events in B. So the union would be everything in both A and B. To find this, I need to take all the events in A and add them to all the events in B, but subtract where they overlap, because I don't want to count two values more than once. This part is called the intersection. And it's represented by the upside down U. This symbol represents the union symbol. Okay, so now that we've visualized our formula and we've labeled that the probability of a heart is A and the probability of drawing a king is B, let's find these probabilities and then plug them into our formula. First, we'll find the probability of A. We've labeled A as getting a heart, so this is going to be the probability of drawing a heart. If we examine the 52 card deck, there's 4 suits in the deck, and each suit has 13 cards. So there's 13 hearts out of 52 cards. So the probability of drawing a heart is 13 out of 52. Now we're going to find the probability of B. We've said that the event B is drawing a king, so the probability of B will be the probability of drawing a king. There are 4 kings in a deck of 52 cards, so the probability is 4 out of 52. Next, we want to find the probability of A intersection B. This will be the probability of drawing a heart and a king. So we need to ask ourselves how many cards in the 52 card deck are a heart and a king. So king of hearts, how many cards are there? There's only 1 card that's a king of hearts. So my probability is 1 out of 52. Now that I've found all of my probabilities for my formula, I'll just plug these numbers in. So the probability of A union B, which is the probability of drawing a heart or a king, is equal to 13 over 52 plus 4 over 52 minus 1 over 52. We'll solve this equation from left to right. 13 over 52 plus 4 over 52 is 17 over 52. And then we'll subtract 1 over 52. 17 minus 1 is 16, so my probability is 16 over 52. Now I need to simplify this. Both 16 and 52 are divisible by 4, so I'll divide the top and bottom of the fraction by 4. 16 divided by 4 is 4, and 52 divided by 4 is 13. Therefore, the probability of drawing a heart or a king is 4 over 13. Question 4. Assume that A and B are events. If the probability of A union B equals 0.9, the probability of A equals 0.6, and the probability of B equals 0.65, find the probability of A intersection B. We are going to use the union formula for probabilities to solve this question. The union formula is the probability of A union B equals the probability of A plus the probability of B minus the probability of A intersection B. We're going to use this formula, substitute in our values, and solve for the missing value, which is the probability of A intersection B. So let's begin by substituting all of our values into the formula. The probability of A union B is 0.9. This is going to equal the probability of A, which is 0.6, plus the probability of B, which is 0.65, minus the probability of A intersection B. And this is the value that we're asked to find. First, we'll add our numbers on the right-hand side of the equation. 0.6 plus 0.65 is 1.25. And I'm just going to rewrite my equation on the next line. Next, I'm going to move the probability of A intersection B to the left-hand side of the equation to make this value positive. Right now, it's a negative value because there's a minus sign next to it. So I'm going to add the probability of A intersection B to both sides of the equation to make it positive. On the right-hand side, I'm left with 1.25. On the left-hand side, I have the probability of A intersection B plus 0.9. Next, I want to get the probability of A intersection B by itself on the left-hand side, so I'll do the opposite of plus 0.9 and subtract 0.9 on both sides of the equation. Therefore, the probability of A intersection B equals 1.25 minus 0.9, which is 0.35. And this is my answer. Question 5. If the probability of A union B equals 0.9, the probability of A equals 0.6, and the probability of A intersection B equals 0.35, find the probability of B. Assume that A and B are events. We're going to use the same formula as we did with the last question. This is the union formula for probabilities, which is the probability of A union B equals the probability of A plus the probability of B minus the probability of A intersection B. First, I'm going to substitute all of my given values into the equation. The probability of A union B is 0.9. The probability of A is 0.6. I don't know the probability of B, but I do know the probability of A intersection B, which is 0.35. Next, I'm going to combine my numbers on the right-hand side of the equation. To do this, I'll do 0.6 minus 0.35. When I subtract those two numbers, I get 0.25, and then plus the probability of B, and that equals 0.9. Next, I want to get the probability of B by itself. So I can subtract 0.25 on both sides of the equation. Therefore, the probability of B equals 0.9 minus 0.25. When we do that, we get that the probability of B equals 0.65, and that's my answer. I usually write my answer portion on the right-hand side of the equation, so we can switch this around real quick and say that the probability of B equals 0.65. Question 6. An employee at an electronics store earns both a salary and a monthly commission as a sales representative. The following table lists her estimates of probabilities of earning various commissions each week. What is the probability that she will earn at least $1,000? For this problem, we're asked to find the probability of an employee earning at least $1,000. And we're going to use the table to the right to solve. If we look at this table, we have the commission, and then we have the probability of earning that commission. We want to find the probability of earning at least $1,000. So this means that we're finding the probability of greater than or equal to $1,000. If we look at the table and we search for the cell that equals $1,000, that would be this one, because the commission is from 1,000 to 1,249. So at least 1,000 would be the sum of all of these cells. We could solve this problem two ways. The first way, we could use the complement formula. The second way is we could simply add up all these values to figure out the probability of earning at least 1,000. But since this video is about complements, we're going to practice using the complement formula. The complement formula is the probability of A equals 1 minus the probability of not A, or the complement of A. A is the event at least $1,000. So the probability of earning at least $1,000 equals 1 minus the opposite of earning at least $1,000. And the opposite of earning at least 1,000 is less than 1,000. Next, we'll use the table and substitute the values into the formula. I know right away by looking at the table what the probability of earning less than $1,000 is. It's 0.11. So I can simply substitute that into my formula and solve. And right away, I'll have the probability of earning at least $1,000. 1 minus 0.11 is 0.89. So the probability of earning at least 1,000 is 0.89, or 89%. This way was a lot quicker than adding up all of these individual probabilities. So that's why we chose to use the complement formula. Question 7. A college administration has conducted a study of 250 randomly selected students to determine the relationship between satisfaction with academic advisement and academic success. They obtained the following information. Of the 90 students on academic probation, 63 are not satisfied with advisement. However, only 16 of the students not on academic probation are dissatisfied with advisement. What is the probability that a student selected at random is on academic probation and is satisfied with advisement? When I have a lengthy word problem like this, I like to break it down and write down the information that is known or given to me, especially the number portion. So let's summarize this question by writing down some key facts. In the first sentence, I'm told that a study was conducted of 250 students. So there's 250 students in all. Next, I'm told that of the 90 students on academic probation, 63 are not satisfied with advisement. So 90 students are on academic probation. And of those 90 students, 63 are not satisfied. So 63 students are on academic probation and dissatisfied. Next, it says only 16 of the students not on academic probation are dissatisfied. So 16 students, these students are not on academic probation. And they are dissatisfied. I'm asked to find the probability that a student selected at random is on academic probation and is satisfied. So we want to know the probability of a student on academic probation and satisfied. If we look at the notes that we took, we can see that 90 students were on academic probation. And 63 of those students were dissatisfied. So that means that 63 out of 90 students were on academic probation and dissatisfied. So if we want to find out how many students were on academic probation and satisfied, so the opposite of this, all we would need to do is take 90 and subtract 63 from it. 90 minus 63 is 27. So this means that 27 students who were on academic probation were also satisfied. So the probability of a student being satisfied and on academic probation is 27 out of the entire student population, which was 250. And this is our answer. Question 8. A manufacturer has shipped 60 stereos to an electronics store, of which 12 are defective. If the electronics store sold 20 cameras before discovering that some were defective, what is the probability that at least one defective stereo was sold? Hint, we're going to use the combination of 48-20 over the combination 60-20. That probability is the probability that no defective stereos were sold. To solve this question, we're asked to find the probability of at least one defective stereo. We'll use the complement formula to solve this. So in order to use the complement formula, we need to know what the opposite of this event is. So the opposite of at least one defective stereo is no defective stereos. So A complement, or the opposite of this event, is equal to the probability of no defective stereos sold. Our complete formula will be the probability of A equals 1 minus the probability of A complement. And the probability of at least one defective stereo sold is our probability of A. The problem tells us that this formula represents the probability that no defective stereos were sold. So we'll plug that into our formula. P of A equals 1 minus the combination of 48-20 divided by the combination of 60-20. So the combination 48-20 gives us the number of stereos that were sold and were not defective. The combination 60-20 gives us all stereos that were sold, including the defective ones. We'll use the combination formula to solve. The combination formula is C n choose R, which equals n factorial divided by r factorial times n minus r factorial. I'm not going to use the combination formula to solve this probability. I encourage you to review the combination video in order to see how to solve this. When I do my calculation for C48-20, I'll get a number which is written below. So we have 167356794499896, and this is a fairly large number. The combination of 60-20 is 41918445058054995. Next, we'll divide these two numbers to get a decimal. Our decimal value is 0.003992438. And we'll finish our probability formula by calculating 1 minus that decimal. And when we do that calculation, we get that the probability of A, or the probability of at least one defective stereo, is 0.996007562. This concludes the Unit 6 video on complements and unions.